Hello, this is Dr. Balaji Srikanth who is going to handle object-oriented programming through Java. Let's start off with Unit 1. This is the syllabus for Unit 1, which is covered totally in the chapters of 1, 2, 3, 4, and 5 of the textbook Java Complete Reference by Herbert Schild. That's also the prescribed textbook which is prescribed in your syllabus. Actually, the Unit 1 is divided into three parts, namely Introduction, Java Basics, and Control Statements. As far as the introduction is concerned, it gives you the introductory part as the name goes by and the basic principles using which Java is implemented. Whereas the second part as well as the third part, which is Java Basics and Control Statements, are very useful for you to write correct programs. These Java Basics and Control Statements, these two parts deals with the syntax and semantics of the rudiments, that is the basic elements of Java. Let's move on to the next slide. Java Introduction. Why Java was created? At one point of time, when the consumer electronics were automated, that is they were having a little bit of intelligence, that is they were able to do things on their own, there was a necessity that these consumer electronics such as fridge, microwave oven, washing machine, TV all had different programming languages, and individually they were having different programs written with different programming languages. Now there was a necessity to use one single programming language irrespective of the consumer electronics manufactured by different companies. They wanted a single programming language using which if they write the program, all the electronic products could be controlled. And to some extent people were successful, and that's what Java language was created. However, it was not so popular as it was expected to. At the same time, at the other end of the world, something was coming up called as internet. In the internet, many different computers, many different systems, many different networking elements from different manufacturers using different operating systems wanted to communicate among themselves without any hassles. However, they were finding it difficult, and when the craving nature of the internet as well as the basic philosophy of Java merged together, Java became a roaring successful programming language, and that's how we are learning Java programming language. Let's now start with Java buzzwords. That is, these are all the features, basic features of Java. Simple. How Java is simple? If you have an understanding of OOPS programming language, that is object oriented programming language, then it will be easier for you. If you have the basic knowledge of the syntax of C and C++, then it will be still more easier, because the syntax of Java program was inherited from C or C++ programming language. That way it is simple. However, this writing of Java programs, once you know the basic syntax, it will be easier and it will be easily could be understood. Moreover, the complicated features such as pointers and the operator overloading feature of C++ were not included in this programming language. It is secure. How Java is secure? It uses virtual machine sandbox model of execution of programs. Okay. In Java, the Java programs are executed on a Java virtual machine. It is, in short, it is called as JVM. There is something called as class loader, which is a part of Java runtime environment. This Java runtime environment is shortly called as JRE. This class loader loads the Java programs on top of this Java virtual machine, and when the Java programs are executing, it restricts the program from accessing the local hard disk or the file system unnecessarily. Also, it does not allow the executing Java programs to unnecessarily access the memory. there is yet another feature called bytecode verifier. This bytecode verifier verifies the code for any illegal code that violates the security. What happens? There is a kind of attack called injection of code. So people might inject their code into our existing code, and this might do malicious activity. Therefore, the bytecode verifier checks for this illegal codes. Okay, and moreover, Java has provided a security framework in the name of java.security. It's a package available in Java. Let's move on to the next feature. Java is portable. How Java is portable? It is also known, it could be also called as architecture neutral. And what is the philosophy of Java? Write once and running anywhere. You write the program in one operating system or in a computer having a different hardware, and just copy the compiled code, execute it in any other operating system or any other different hardware system without compiling. That is the philosophy of Java. To achieve this, Java provides two components, namely a runtime environment for the execution of the program. Application programming interface. Application programming interface means Java gives you many built-in features or a library, a huge collection of library of functions. In object-oriented programming paradigm, these functions are all called as methods, using which we can write elegant codes. Java programs are compiled and converted to bytecode. These bytecodes are executed on top of the Java virtual machine. Therefore, if you copy just the bytecodes to any other platform which contains a Java virtual machine, automatically the program executes. And here you need not recompile. This is unique to Java, and whereas in the case of C or C++ or any other programming language, this cannot be done. Either you will have to write the entire program or you will have to recompile, so that the compiled code is compatible with the underlying operating system or the hardware. And this has been taken from javat.com website. Object-oriented programming paradigm. Java follows object-oriented programming paradigm. What is this object-oriented programming paradigm? This is a programming paradigm or a specific way of designing a program or software. Okay, it allows us to think of the data in our program in terms of real-world objects with both properties and behavior. Properties could be data. Properties define the state of the object, and behavior defines the actions our object can make. And this programming paradigm simplifies the software development and the maintenance. Everything in Java is an object. That is, everything in Java is considered as an object. The basic concepts of this programming paradigm is object, class, inheritance, polymorphism, abstraction, and encapsulation. Java programs are robust. How? When the program is developed, it is forced to check for errors in the early development stage of the program. Memory management. Memory management is done beautifully in Java. When the program is executing, the instance variables or the variables as well as objects which are created will be allocated in the memory, and when its usage is not there, it has to be removed from the memory. In other programming languages, the removal of variables as well as objects from the memory location is the responsibility of the programmers, whereas in the case of Java, it is being taken care of by a low priority thread called as garbage collection. This garbage collecting thread, it checks the memory location for unused objects and it removes. What is the necessity for removing of unused objects? Because when the unused objects as well as variables are occupying the memory location, and there is a Requirement for allocation of memory. There might not be sufficient memory locations for allocation of memory location for new variables. Such a situation is called as memory leak situation. These memory leaks are avoided by the help of garbage collecting threads. Exception handling mechanism. A corrupt program sometimes might not execute properly in some extraordinary or exceptional situations. Java programs, when it encounters such a situation, it handles the situation gracefully by exception handling mechanism. Java programs are multi-threaded. That is, programs could do many things simultaneously. This is because the Java runtime environment is equipped with elegant and sophisticated synchronization facility which will support multi-threaded environment. Architecture neutral. Java programs are architecture neutral. That is, the changes in the underlying hardware as well as the software, that is upgradation, sometimes it might be upgraded. Such a situation will not affect the execution of the program created because this is being taken care of by Java Virtual Machine. And Java Virtual Machine, it executes only the bytecode. When a Java program is compiled, it is compiled into the bytecode, an intermediate code called as bytecode. These bytecodes are running on top of the Java Virtual Machine. Okay. Therefore, the goal of Java, write once, run anywhere, and anytime, forever is achieved. Java programs are interpreted and high performance. As I told you, Java programs are interpreted. How? The programs are compiled into an intermediate code called as bytecodes. These bytecodes are again interpreted on top of the Java virtual machine. That is, Java programs are executed by means of interpreters. And to provide high performance, the bytecodes are compiled by just-in-time compiler to the underlying hardware or operating system to improve the performance. Even though the programs are interpreted in the absence of a just-in-time compiler, the interpreted programs are executed without sacrificing the performance of Java programs. That is the feature of Java. Java programs are distributed. Java is designed to be executed in a distributed environment. It can handle TCP/IP protocols. Java programs support remote method invocation. What is remote method invocation? That is, a program running in the local system can make a call to a method which is available in a remote system. That's called as remote method invocation. Accessing a resource using an URL is like accessing a file in the underlying hard disk or file system. It is so gracefully written, and the APIs, sufficient APIs are available so that accessing a resource using an URL will be like accessing a file in the underlying file system in the hard disk. Java programs are dynamic. Programs carry sufficient information to verify and resolve accesses to objects during the runtime. Small fragments of bytecodes may be dynamically updated on a running system. Now, let us see how Java programs are architecture neutral or portable. This is the computer hardware. On top of the computer hardware sits the operating system. On top of the operating system sits the Java virtual machine. The Java programs work on top of Java virtual machine. Therefore, this Java virtual machine takes care of the translation or the accessing of the underlying hardware as well as the operating system in a secured manner. Now, the Java programs remains the same. The computer hardware changes, the operating system changes. However, the Java virtual machine compatible with Windows operating system is brought in. Therefore, the Java program is not changed or it is not even recompiled. The bytecodes, the compiled intermediate code called as bytecodes, remains the same, and the Java virtual machine which is compatible with the underlying operating system as well as the hardware is taken care of. Now let us change another operating system. The Java program remains the same, the computer hardware changes, and we have a Linux operating system. Now the Java virtual machine, which is compatible with Linux operating system, comes into place. Therefore the portability is achieved. Again, I'll change another operating system. The computer hardware changes. For it, the Apple Mac OS on top of it is installed, and Java virtual machine, which is compatible with Apple Macintosh, is brought into place. Therefore there is no necessity for the Java programs to be recompiled, or not even any chance of rewriting the entire program. Okay, again the computer hardware changes, the operating system changes to Android operating system. A virtual machine which is compatible with that operating system is brought into place. Therefore the Java programs are need not recompiled or need not be changed. Okay, so along with each and every operating system, the Java virtual machine is downloaded. The compatible Java virtual machine is downloaded and it is in place. So the moment you copy the Java programs, that is the bytecodes, it starts executing. Now let us take up the programming paradigm. There are two different kinds of programming paradigm, namely process oriented model and object oriented model. The process oriented model was the legacy model which was followed by programming languages such as C as well as C++. It is characterized as a series of linear steps. Okay, the code acts on the data. The problem with this approach is the larger the programs, more complex it will be to handle as well as maintain. If the problem for which we are writing the program is very complex, again the complexity increases multifold. Whereas in the case of object-oriented programming paradigm, it's not so. This OOPS paradigm organizes the program around its data, that is objects, and a set of well-defined interfaces to access those data. It is characterized as a data controlling the access to a code. In fact, the data is controlling which code to be accessed and which code should not be accessed. Here the controlling entity is the data. Object-oriented programming paradigm, we saw the principles or the concepts, basic concepts. Now we will see a little bit in brief. It organizes and manages complex programs and the program size increases, so that the maintenance, the development, the maintenance will be easily done. The main principles of object-oriented programming paradigm are abstraction, inheritance, encapsulation, and polymorphism. What do you mean by abstraction? It is the process of hiding the complexity of information. Only the essential information is shown. The non-essential information is not shown to non-essential users or non-essential objects of which can access the code. It separates the behavior from implementation. Sometimes the implementation details will not be given, and whichever object has to make use of the code has to provide the implementation for the code. That is the meaning here. How it is achieved? It is achieved, this abstraction is achieved using a keyword called as abstract. And you can create abstract classes, abstract methods, and also another feature called as interfaces. Now let us take an example, a real life example of what is this abstraction. In order to drive a car, the essential details such as the accelerator pedal, the brake as well as the clutch pedal, and the gear movement and the steering control should be known for any driver. Whereas the other complexities such as how the engine works, how the gear change is transmitted, how it affects the speed, as well as how the brakes work when you press the brake pedal, how it is being applied, what is the mechanism behind the brake, are all hidden from the drivers, that is the actual users. This abstraction is used to create user-defined data type. Encapsulation mechanism. This mechanism is used to bind the code as well as the data it manipulates on. This encapsulation mechanism, it prevents data from being accessed by the code outside. In other words, it gives a protected access to the data by a code. It seals the code, or it seals the data inside a class and could be accessed only methods declared inside the class. How? Variables or data of a class cannot be directly accessed by other classes. It should be and it has to be accessed only through methods declared inside the same class. We'll see it why. Data in a class is hidden by declaring them private. How do I declare a data as, or how do I hide a data? By declaring them as private, I cannot access the data from outside the class. If at all I have to access that particular data, then I'll have to access that particular data by means of an interface called as method, which is accessing the data. So this is a combination of data hiding as well as abstraction. How encapsulation is achieved? By declaring all the variables in a class as private and accessing those variables using a public method which is defined inside the class, this encapsulation is achieved. This slide shows whatever was discussed in the previous slide. The white triangles signifies public methods. The dark triangles are private methods. Then the shaded circles are private variables, and these variables are called as instance variable, whereas the thatched or circles, small circles, which is outside the bigger circle called as class, are called as public variables. Usually public variables are not recommended in all the situation. In extraordinary situation, you might declare one or two variables as public. Again, that is also not recommended. Now, how encapsulation is achieved here? When you declare the variable as private, you cannot access it from outside. You access it using the public methods. These public methods can access the private methods which are declared inside the class, like this. Another code trying to access it directly, it is not allowed. It is being taken care of by the Java runtime environment or the compiler itself. So what is the use of encapsulation? You can modify the underlying instance variable. You can upgrade it. You can modify it with transparently to the users, transparently to the code which is using from outside. Then inheritance. Inheritance is a mechanism by which one class acquires the features, that is the properties, that is fields and methods of another class. For example, a child class inherits the traits of his or her parents. What is the advantage of inheritance? It facilitates reusability. The fields and methods of an existing class is reused. In order to learn this inheritance, we should know the following terminology, namely the superclass as well as subclass. Superclass, it is those classes features that are inherited by the subclass. The subclass, the class that inherits other class is known as a subclass. It is also called as a derived class or extended class or child class. The subclass, after inheriting, can add its own fields and methods in addition to the superclass fields and methods. Here, one point worth mentioning is if the superclass or the parent class or the base class is having any private members, it will not be inherited in the subclass or derived class or child class. This slide shows examples of two types of inheritance. The first inheritance is animal. Here in this, animal is the superclass and dogs as well as cat are two subclasses which inherits the properties of animal. The next example is this Lion King family. In this Lion King family, it is in this lineage, Mufasa is the superclass. This is a super class, and Simba, the son of Mufasa, this is the subclass. Here we have seen example for two types of inheritance. Of course, there are many other different types of inheritance which we will be seeing in the subsequent units. Polymorphism is a mechanism which allows to perform a single action in different ways. It is also a mechanism which allows us to define one interface and provide different implementation for the same interface. The word polymorphism is from Greek. If you dissect the word polymorphism, poly and morph, poly means many and morph means forms. So if an object takes any different forms, then it is said to exhibit polymorphism. There are two different types of polymorphism, namely compile time polymorphism, also known as static polymorphism, runtime polymorphism, or dynamic polymorphism. These are the two types of polymorphism. To take up a real life example, how polymorphism is exhibited, a student studying in a college, when he comes to the college, he is a student. When he goes home, he is the son or he is the daughter. When he goes to his relative's house, he becomes niece or nephew. When he goes to his father's company, suppose his father is having his or her father is having a company, then he becomes the owner of the company. Okay, so the same object student exhibits different behavior depending on the situation. Therefore, polymorphism is exhibited like this in the real life. Data hiding is a feature of object-oriented programming languages. This feature does not allow an object's data to be accessed directly by other programs. Rather, the methods declared inside the class are used for accessing the data. The advantage of having hidden data is to hide the data and safeguard the data from accidental alteration. Another advantage is the underlying data might be changed or upgraded without affecting the codes using that data. Application of object-oriented programming principles. The main pillars of object-oriented paradigm, such as polymorphism, encapsulation, and inheritance, they don't work individually, rather they work in combination. They work together to produce a scalable, robust, a cohesive, maintainable code, which is far better than a program developed by the process-oriented programming paradigm. The hierarchy of classes aids in reusing a time-tested code. That is, the inheritance, it enables the users or the programmers to reuse the already existing code. A real-life example for this inheritance is all drivers rely on inheritance to drive different types of vehicle. The vehicle is a superclass and the different types of vehicles are subclasses. A vehicle could be a school bus or a Mercedes sedan car or a Porsche car or any other car, or it might even be a family van. But the drivers operate all these vehicles with the knowledge of steering wheel, brakes and accelerator. Encapsulation helps to migrate the existing code over time without affecting any other part of the code which is dependent on. People interface with encapsulated features on cars all the time. For example, the brake and the accelerator pedals hide a large set of complex mechanical parts so that simply they may be operated with the feet in the case of cars. Polymorphism allows to create clean, sensible, readable and resilient code. Irrespective of the type of brake, whether it is an anti-lock braking system or an ordinary braking system, the driver simply has to press the brake pedal to stop the car. The same interface can be used to control a number of other different implementations of braking system. This slide shows our first Java program. The first line, this is called as a multi-line command, and the Java program starts here with a keyword class and it ends with a closing flower bracket. This rectangle, it shows the output screen. I have copy pasted the output screen, the output of the execution of the given Java program. Actually, this output shows the two steps of executing a Java program. The output here is, this is a simple Java program. This is displayed here. See here, it is displayed. Okay. How to run a Java program? Type the program in any text editor such as Notepad. Save the file using with the same name as that of the class and with a .java extension. Suppose if the name of the class is example, it is saved as example.java. Exit the text editor. Now come to the command prompt. How do I come to the command prompt? Press the start key, type cmd and press enter. A command window pops up with this prompt and a cursor blinking by the side of this prompt. It is displayed. Now in this command prompt, see here, in this command prompt you type this command javac example.java. Javac means Java compiler. Example.java is the program which you have written. You have saved in using Notepad, is it not? That program. Now when you, after pressing enter, this command creates a file called as example.class. This file contains the intermediate code called as bytecodes. In the command window, again you type the following command, java example. The following output is displayed in the command prompt window. This is a simple Java program which we have given in the system.out.println. Okay. Now we will dissect the program. Multi-line comment. This is single line comment. Class is a keyword, that is, it is given by the language. It has got some meaning. So you cannot use this keyword for any other purpose. Let us take up another program. In this program, what we are doing here is we are declaring a variable of type integer, which means we can store integer type values, and we are initializing 100 to this variable. That is, we are giving its first value. Now we are printing the value what it is contained in num. It should print 100. We are performing a simple calculation, that is, we are multiplying this num by 2 and we are printing the value of this multiplied value. We will see what happens when we execute. See here, initially the value is 100. Now the value after multiplication is 200. Structure of a Java program. The structure of a Java program specifies that if you are writing a Java program, then it should follow for this structure. The first statement, it is not mandatory. If at all you are having package statement, then it should come first. Then if you are importing any packages, then it should come in the second line. It should come here. Afterwards comes the class followed by your class name. You have to put a opening flower bracket. For this opening flower bracket, the corresponding closing flower bracket here. In between, you can declare any number of variables. You can have constructors, functions, it is called as methods, and one main function. This is the signature of main method. Public, static, void, main, string, args. It takes a argument, a string array as its argument. Now we'll take up Java basics. Yeah, the topics to be discussed in Java basics are buzzwords. The buzzwords we have already discussed. Now we will take up the data types in Java. Java is a strongly typed language. What do you mean by this strongly typed language? Every variable has a type. Every expression has a type, and every type is strictly defined. All assignment statements are explicit assignment statement or parameter passing statements. When assignment statements are executed, it is checked for type compatibility. If type compatibility is violated, then compiler error is generated. Then there is something called as automatic conversion or conversion is done only for compatible types. Java checks all expressions and parameters to ensure type compatibility. Mismatches lead to compiler error. This slide gives the example of or the classification of the data types in Java. It is data types in Java is broadly classified into primitive data types and non-primitive data types. These non-primitive data types are divided into string, array, and other user-defined data types. Whereas primitive data types are again subdivided into Boolean type and numeric type. Boolean type means the only type it has got, subtype it has got is Boolean. The values it can take is true or false. Whereas the numeric data type is again divided into character value and integral value. The character value, it is character. Character means it can take up only one single character which is enclosed within single quote. Okay. This integral value is again divided into integer type and floating point type. This is integer will not contain any decimal points, whereas floating point will contain decimal points, and it is used for representing precise values. In integer, we have other subtypes such as byte, short, int, long. In floating point, we have two types, namely float and double. The data types, whatever I have shown pictorially, I have given the description here in the slide. Now let us take up each and every data type individually. Short. Short is a signed 16-bit integer type. The range is -32768 to 32,767. It is the most leastly used Java type. Example declarations are short s and t. Integer. Most commonly used data type is integer data type. The size is signed 32-bit and the range is given here. Declarations are int I, int I and int j. Long is another data type which is used to store really large values. These large values, if they are stored in the integer type data type, they will be lost. It will overflow because the integer data type cannot hold such values because it is not wide enough. The size of long data type is 64-bit and the range of long data type is displayed here. And this is how you will declare long data type. Let us take up the light program example. In this program, I have declared three variables, namely days, sec, and distance as long data type. And I have done some calculations and I am displaying the result of the calculation here. Now, let us execute this program. Java C space light light.java. It got compiled. Now Java light. I am executing the program. See here, the value which is displayed here cannot be stored in an integer data type. Okay, very good, fine. Now let's get back to our presentation. Normally, fractional numbers or decimal numbers will be used to represent precision. Such precision values will be stored in floating point data types. It is also called as real number. Float specifies a single precision value. The size of float is 32-bit, of course signed. The range of float is 1.4 raised to the power negative 45 to 3.4 raised to the power 38. Example declaration is shown in this line. Float is the keyword followed by variable names. The variable names are comma separated. You can give as many number of variables as it is required. However, the last line, the last variable should be followed by a semicolon, that is terminating that line. These floating point, when included in computation, they are faster than double precision. Of course, they are lesser precise when compared to double, and also they occupy lesser space when compared to double. Double data type is similar to floating point data type. However, whenever accuracy is required, double data type is used. Moreover, when storing really large floating point numbers, double data type is used. The size of double is 64-bit and the range of double is given like this: 4.9 raised to the power minus 324 to 1.8 raised to the power 308. Example double declaration. Double is the keyword and these are all the variable names D and H. Let us take up a sample program which uses double data type. This program makes use of double data type. I have declared three variables, namely pi, r, a. I have given some values to r. Pi value, of course, you know that it is 3.1416, and I am calculating the area of a circle. I am displaying the area of circle, and let me execute this program. Java C area dot Java area. Of course, since I have used only 4 decimal numbers after the decimal point, it gives me this many number of numbers. However, if I go in for a high precision value such as 10 decimal points or 10 decimal places or 20 decimal places, it will definitely display. Now let us get back to our presentation. In Java, the data type used to store characters is char. Java uses Unicode to represent characters. Unicode defines a fully international character set that can represent all the characters found in all human languages. It is a unification of dozens of character sets such as Latin, Greek, Arabic, Cyrillic, Hebrew, Katakana, Hangul, and many more. At the time of Java's creation, Unicode required only 16 bits. Therefore, Java char data type is only 16-bit long. The range of a char is 0 to 65,536. There are no negative characters. The standard set of characters known as ASCII is still ranging from 0 to 127 as always. And the extended 8-bit character set ISO Latin 1 ranges from 0 to 255. Since Java is designed to allow programs to be written for worldwide usage, it makes sense that it would use Unicode to represent its characters. Of course, the use of Unicode is somewhat inefficient for languages such as English, German, Spanish, or French, where the characters could be easily contained or represented using 8 bits. But a price has to be paid for the global portability, and this is the price we are paying. Let us take up a sample program. The name of the program is char demo. Here I have declared two variables ch1 and ch2 as char type variables. For ch1 I am assigning a value 88 and for ch2 I am assigning a value y, which is uppercase. If you observe keenly here, the value y is enclosed within a pair of single quotes and there is only one single character. Therefore, what should be understood here is the character literals should be enclosed in a pair of single quotes and it can contain only one character value. If I execute this program, it gives me a value char demo. See here, the value of ch1 is printed as x. Actually, 88 is the numeric equivalent of the uppercase character x. Therefore, it prints the value x when I am assigning the numeric equivalent. Thinking in the same line, we can perform arithmetic operations such as addition and subtraction on character data type. Let us now move on to the next slide. Java has a primitive data type called Boolean for holding the logical values. It can have either a true or a false value. That is, it can have only one of two possible values. This is the type written by all relational operators such as less than or greater than or equal to or not equal to. For example, if A is greater than B or A is less than B or A is equal to B, A not equal to B. Boolean is also the type required by the conditional expressions that govern the control statements such as if and in for loops. The name of the program is bool test and I have declared a variable b of type boolean. This variable b can take only two types of values, namely false or true. I have assigned false and I am printing the value. Again I am changing it to true and then I am printing the value. Now instead of using any relational operator, straight away I am using this variable in the if statement and I am printing the result. Let us execute and check what happens if I execute the program. Java C bool test.java Java bool test. See here, this B is false corresponds to this statement and B is true corresponds to this statement. See here, if B, since B is true, the if statement, body of the if statement is executed. That's why this is executed. And when I change it to B is equal to false, what happens? That particular statement, this is not executed, this line, this is not executed, it's not displayed. And system, I am using the relational operator straight away in the system.out.println and I am printing what it will print. The output of this relational operator is printed as true here. Let us move on to the next slide. This slide gives the summary of all the data types discussed so far. This column, the second column, it briefly describes each and every data type. This column, it specifies what is the default value assigned to each and every data type variables. This column gives the size of each and every data type in bits. This column gives the example possible literal values that each and every data type can hold, and the last column specifies the range of values each and every data type can hold. This slide gives the Java keywords. Though it is not specified in the syllabus, it's worth mentioning these keywords because every Java programmer is expected to know these keywords thoroughly. And if you go through the keywords carefully, some keywords will be having single dot, some keywords will be having 3 dots, some other keyword will be having 4 dots, and here this keyword is having 2 dots. Single dot is not used. 2 dot means it was added in Java version 1.2. 3 dot means it was added in Java version 1.4. And 4 dot means it was added in Java version 5.0 onwards. Some of the keywords, though they are available, they are discouraged to be used in the Java programs. Again, this slide lists out the Java keyword, of course in a categorized manner. The first column lists out the keywords used in primitive data types. The second column lists out the keywords which are used as modifiers, of course access modification. And the third column lists out the keywords which are used for declarations. Fourth column lists out the keywords used as control flow or control changing keywords. And the last one, it consists of a mixture of keywords which has different purposes. Overflow and underflow conditions results in arithmetic operations. Overflow is the condition where there is a maximum value for a particular data type, and if the value is incremented, it results in overflow. Similarly, underflow is a situation where the minimum value is again decremented. Both overflow and underflow results in unexpected values, and it will not throw any runtime exceptions. Of course, the overflowing or underflowing are predictable and reproducible. Literal values. The integer literals are worth mentioning here. Integer literals could be represented as binary, octal, or hexadecimal. For octal representation or octal numbers, it is prefixed, the numbers are prefixed with a 0. It is given here. And for hexadecimal, it is prefixed with 0x. The x might be lowercase or uppercase. And for binary, it is 0b. Character literals could be represented using a 16-bit character values. It could be converted into integers, and character literals could be manipulated with integer operators. And character literals are represented within a pair of single quotes, and there could be only one single character within the pair of single quote, as shown here. It is impossible to enter characters use escape sequences. Okay, which will escape sequences are discussed in the next slide. Value of character could be entered directly in octal. For example, in octal followed by 3-digit number slash 141, that is backslash 141 represents A. In hexadecimal value, we represent like this, backslash U followed by 4 hexadecimal digits. That is, for example, backslash U 0061 is representing lowercase a. This slide gives an idea of what are all the escape sequences that could be used. Of course, backslash followed by 3 numbers is used for representing characters using octal values, and this backslash U followed by 4 numbers, it is used for representing hexadecimal Unicode character. Backslash single quote is represented used for representing single quote, and again backslash double quote is used for representing double quote inside a string. In order to represent a backslash inside a string, we use this escape sequence, and to represent carriage return, we use this sequence. Likewise, we use these following sequences for representing inside a character. String literals. String literals are enclosed within double quotes. These are all the examples of string literals. Hello world. Anything you include within a double quote, it becomes a string. Here, the second example, it goes like this: 2 followed by an escape sequence /n lines followed by another escape sequence. This is in quotes. Okay, so what happens? Hello world, then it will display two lines. Again, this is in quotes is represented within a double quote. Of course, octal or hexadecimal notations and escape sequences work the same as in character literals. Java strings must begin and end with on the same line. Variables are the basic storage unit of Java programs. The general syntax of variable declaration is data type, whether it is integer, float, followed by the variable name. And at the time of declaration itself, you can initialize it. The general syntax for variable declaration combined with initialization is given here. And if you look at the example, it might be clear. Int ABC, int d is equal to 3, f is equal to 5. Here it is a combination of both declaration as well as initialization at the time of declaration itself. Variables could be initialized dynamically using expressions also. Scope and lifetime of variables. Block begins with an opening curly brace and ends with a closing curly brace. This is a block. Any statement or any number of statements within opening and closing curly braces is called as a block. This block defines the scope. The scope determines which objects or variables are visible to other parts of your program. The scope determines the lifetime of a variable or objects. Variables declared inside a scope are not visible to code that is defined outside the scope. Once the program execution goes past the closing curly braces, the block ends. Once the block ends, the lifetime of the variable also ends. Therefore, the value held in those variables are lost. Variables are created when their scope is entered and destroyed when their scope is left. Variables will not hold their values between method calls because these values will be stored in a stack. Lifetime of a variable is confined to its scope and blocks could be nested. Now we'll take up something called as casting. What is casting? Suppose I have two variables, I which is of type integer and L which is of type long. I is 32-bit, long is L is 64-bit. Now if I assign the value of stored in L to integer I as the diagram specifies, L is a larger bucket. If I pour the contents of larger bucket into I, a smaller bucket comparatively, there will be definitely overflow. And this casting is not done automatically. See here, I am assigning the values stored in the variable L of type long to I type integer. See, L contains larger value larger than I. So when I am doing this, I will definitely lose data. Therefore, in order to make the compiler understand that I know that there will be loss of data, I will have to give this data type enclosed within parenthesis. Which is the target data type here? Integer. Therefore, I will enclose the target data type inside the parenthesis. And when I am assigning this integer value stored in I to a long which is to be stored in L, it is widening. So I don't need that kind of parenthesis. This is called as automatic promotion or coercion, which we have seen several slides back. This is widening and the previous one is narrowing. The primitive numbers, again the primitive data types, their size and the range is displayed here. Now this slide gives the casting of primitives. So if I am casting a byte to character, then I have to cast. Short to character, casting. I to character, I have to cast. So if you go through the slide leisurely, you will know which are all to be casted. That is, when I am assigning a larger value into a smaller value, I have to cast. Whereas when I am assigning a smaller value into a larger value, that is widening, when widening is happening, promotion, automatic promotion or coercion is happening. Therefore, I need not specify the data type inside by the side of the target. So these are all the acceptable implicit casts. Byte byte values can be stored in short values could be stored in integer type, and integer value could be stored in long, and long value could be stored in float. Even though the size is smaller, it has got precision, therefore it has got advantage. And float values could be stored in double automatically. Moreover, character values could be stored in integer, whereas the reverse is, and this is called as automatic promotion, whereas the reverse is not allowed. It is not done automatically. You have to explicitly specify that. See here, these are all illegal, whereas this is legal. This is illegal. Why? I'm trying to store a long value into byte, float value into long, short value into character. The left hand side of the assignment is always shorter than the right hand side, therefore it is illegal. So if I have to make it legal, I'll have to specify the character target data type here within parentheses, whereas this is okay. Why? Because I am assigning a shorter value into a larger data type. Automatic promotion with arithmetic. What is this automatic promotion with arithmetic? When you are performing an arithmetic operation, automatically what happens? The arithmetic is never done in 8-bit or 16-bit containers. Of course, it is done in 32-bit containers. Therefore, what you have to do, you will have to take care of it. How? If I am performing an addition operation between a short data type variable and a byte data type variable, this line will produce compiler error. Why? Because I am performing this arithmetic operation using integer data type. Therefore, what I have to do is I will have to specify that this integer data type has to be converted into short. So the corrected version is given here on the right hand side. Casting and promotion happens even during method calls also. For example, let us take up a built-in method called index of, which will take an integer value as argument. Suppose if you are passing a float value, it will not be accepted because integer is smaller than float. Whereas we can call like this: st.index of c, that is character or byte value. This is allowed. Arrays. Arrays are a group of like-typed variables that are referred to by a common name. It can have one or more dimensions. A specific element in an array is accessed by its index. It offers a convenient means of grouping related information. One-dimensional arrays declaration could be done like this: type variable name with followed by a pair of square bracket. If it has to be a two-dimensional array, then it will be followed by another pair of square brackets. The number of pair of square brackets are available, it specifies the number of dimension. This is an example for declaration of a one-dimensional array. New. New is a special operator that allocates memory to the created array. The general syntax for creating array and allocating space is array variable equal to new. What is the data type given here? This followed by the size. For example, for this declared array month of days, we will allocate variable like this. Month days is equal to new. What is the data type? Int 12. So the array month underscore days can store 12 values. The array so far created in two-step process could be created in a single step as follows. Int month underscore days followed by a pair of square bracket is equal to new int followed by the size. So the previous slide we saw how to create an array and allocate memory space in two steps. Both the steps could be combined as shown in this statement, and it is also correct. The following statement assigns value 28 to the second element. Of course, it is given here 1. So it should not be 1, not the first element? No. Why? Because the array values are always starting from 0. The array index are always starting from 0. We can have multi-dimensional arrays. Multi-dimensional arrays are implemented as array of arrays. We specify the additional dimension using a set of square brackets. For example, a two-dimensional array called as 2D is declared as follows. Int 2D, how many pair of square brackets are available? 2 pair of square brackets. Therefore, it is a two-dimensional array. And what is the dimension or what is the size of each dimension? 4 rows and 5 columns. This allocates a 4 by 5 array and assigns it to the variable name 2D. Internally, this matrix is represented as an array of arrays of type int. This is a representation of 2D array. How many rows are there? 1, 2, 3, 4. And how many columns? 1, 2, 3, 4 and 5. The first value always represents the row. The second value represents the column. So in the first column, the column value will be always 0. Second column, it will be 1. Third column, 2. Likewise, in the rows, the first value represents a 0. The first row, the value will be always 0. As far as the memory allocation regarding the multidimensional arrays are concerned, we can first allocate the memory location for the rows alone. Subsequently, we can allocate for the columns differently. The following example shows how it is done. This statement, it defines memory location only for the rows. How? This first square bracket, first set of square bracket represents the rows and the second set of square bracket represents a column. Now it is left empty, therefore memory is not allocated to the columns. If you take up the second line, 2D of 0, 2D of 0 represents the first row of the array, two-dimensional array 2D, and we are allocating memory location for the columns. Okay. Is there any difference between this method and the method seen in the previous slide? Of course, no difference. However, this method, when followed, it is useful in the creation of jagged arrays. What do you mean by jagged array? The example or the figure shown here represents the jagged arrays. Each and every row will have different columns. The column size for each and every row are different. This is an example for a jagged array. See here, first row we assign 3 columns. The second row we assign 2 columns, and the third row we assign some more number of columns, namely 1, 2, 3, 4 and 5 columns. Okay, if we execute the program, we will get the following output. See here, this is a jagged array. Again, this is another example for jagged array. Okay, one more row is added, and this row is having only one column. Arrays can be initialized with values during the declaration also. Okay, this is another way of declaring the arrays. What is the difference here? See here, instead of putting the square brackets after the variable name, we are putting the square brackets before the variable name. That is, we are putting the square brackets near the data type. Note the square brackets are next to the data type. Okay, fine. So what is the advantage? The advantage is when declaring several arrays at the same time, you can specify like this: integer array, nums, nums2, nums3. These are all integer arrays. And when we are returning a value, array value or array from a method, this is very easy. Now let us take up the operators available in Java. Java provides a rich collection of operators. The operators could be divided into the following groups: arithmetic operator, relational operators, bitwise operators, logical operators, assignment operators, and miscellaneous operators. The mathematical operators are listed here, and this is plus, addition, subtraction, multiplication, division, modulus. Modulus means it gives a reminder. This increment double plus plus is incrementing operator, and these arithmetic operators or mathematical operators are combined with equal to, and they are called as addition assignment, subtraction assignment, multiplication assignment, and so on. And this is a decrementing operator. As far as the operands of these arithmetic operators are concerned, it should be of numeric type. You cannot use boolean or character. And the modulus operator, it returns the remainder of a division operation, and it can be applied to floating point types and integer types. Arithmetic operators, especially these compound assignment operators, these are special operators that can be used to combine an arithmetic operation with an assignment. For example, a is equal to a plus 10 would be written as a is equal to a plus equal to 10. The incrementing and decrementing operations take effect in the presence of another operator. Let us take up the bitwise operators. It is applied to integer types such as long, int, short, char, and byte. These operators act upon the individual bits of their operands. See here, this column lists out the bitwise operator, and the right hand side it lists out the bitwise operator with compound assignment statement. 2's complement numbers. These 2's complement number is used to represent both unsigned as well as signed numbers. Okay, the leftmost bit, if it is 0, then it means it is a positive number, and if it is a 1, it is a negative number. Adding 2's complement. Another advantage of having 2's complement is you can use addition for performing subtraction also. The logical operators, that is the ampersand, pipe, this represents OR, this represents exclusive OR, this represents NOT. A is equal to 10 and B is equal to 12. It is represented in the binary form as like this: 1 0 1 0 1 1 0. Okay. This truth table specifies the operations of bitwise operator. A or B means 0. If both A as well as B is 0, then it results in a 0. If any one of the operator is having a operand is having a 1, then it results in a 1. Whereas it is opposite in the case of AND operation. Even if one of the operand is a 0, it results in 0. So when it will result in a 1, only when both the operands are having 1, it will result in a 1. And exclusive OR operator, This exclusive OR operator, it is unique. If both the values are equal, it will result in a 0. If both the values are different, see 0 and 1, it results in a 1. Okay, if it is both the values are 1, it results in a 0. Complement is, if it is a 0, then it will become a 1. And if it is a 1, it will become a 0. This program exemplifies the logical bit operator. Again, these operators are called as shift operators. This is left shift, right shift, and shift filled with zeros. Okay, let us take up the left shift and right shift operators. The values 3 and -4 are represented in the binary form. When I shift to the left, what happens? 3, see here, when I shift first time, this one goes here and this one goes here. And when I shift it to the next time, it is shifted 2 digits. And again, I am representing -4 in binary. Okay, when I shift here, you pump zeros from the right hand side. Whether the leftmost bit is a 1 or not, you will keep on pumping zeros. And when it comes to right shift, it is different. When I shift the last 2 digits to the right, there is no more digits, so it is discarded. Whereas this negative number is concerned, what is here? The leftmost end you have only 1 since it is negative. Therefore, what we do is from the left end we keep on pumping ones. Let us take up the triple shift. This triple shift, irrespective, what is unique about this triple shift? Irrespective of whether the leftmost bit contains a 0 or 1, it will keep on pumping zeros from the left, unlike the double right shift operator. Okay, and this program exemplifies how this left shift, right shift, and triple shift works. Okay, and this is another example for the shift operator. And here in this example, we also say that arithmetic promotion is happening, or automatic arithmetic promotion is happening. Okay, this is another additional example. When I shift it once, 1 0 is discarded. I am shifting it to the right, so 1 0 is discarded, and all the bits are shifted once. Again, when I shift B, see here, this 0 is discarded. That's why we are getting like this. When I shift 1, shift A once to the right with triple shift, it keeps on pumping zeros here. See here, in the case of double shift, since it is 1, you start pumping in ones from the left end, whereas in the triple shift, it is pumping only zeros, irrespective of whether it is a 1 or a 0. This is shifting another time. Relational operators. Relational operators greater than, less than, greater than or equal to, less than or equal to, and equivalent, double equivalent, and not equal to. The result of these relational operators will be always true, that is Boolean. These logical operators are also called as short circuit operators because if one of the operand is true or false, automatically the next operand will not be evaluated and the result is obtained. Boolean logical operators. This represents logical AND, logical OR, and logical exclusive OR. The operations are same like the one which we saw in bitwise operators. This is for logical OR operation. This is for logical NOT operation. Short circuit operators. See here, when this is one operand, this is another operand. If the output of this operand is known, then this operand will not be executed. That's why it is called as short circuit operator. Again, this is another short circuit operator. If the output of this is known, the output of this is this expression will not be evaluated. And this is miscellaneous operator, also called as ternary operator, because it has got three operands. Any expression that evaluates to a Boolean value, if it is true, then expression 1 will be taken. If the Boolean expression is false, then expression 2 will be considered. Ternary operator example program. If the value is true, then true is printed, or else false will be printed. If the value of t is equal to true, then true will be printed, or else false will be printed. Okay. Since we have assigned t is equal to true, true is printed. And see here, since the value of t is true, 1 is printed. That is left hand side expression of the expression before the semicolon. And value of true, since the value of f is false, false is printed, and here 2 will be printed. Is it not? See here. Conditional operator explained again. Checks for the condition. If the expression is true, this is true expression. The expression is false, automatically this value will be assigned to this variable. Assignment revisited. What is so special about this? You can give or you can assign values like this. This is called as chain assignment. It is also possible in Java. Now let us take up control statements. Control statements are used to change the flow of execution, either to advance or to branch to another part of the program based on the state of a variable or outcome of an expression. Totally, there are three control statements. One is selection, next one is iteration, last one is jump statements. Let us take up the selection statements or conditional statements. The conditional statements are if statement, if else statement, nested if else statement, if else ladder statement, and switch statement. It is also known as conditional statement because it lets us choose which statement will be executed next. And this statement, which makes us to select a choice of statement, it is also called as selection statement. Conditional statements gives the power to make basic decisions. If statement. The if statement has the following syntax. If the condition is true, this statement is executed. If is a Java keyword. Okay. If the condition is true, the statement is executed. If it is false, then the statement is skipped. Logic of an if statement. It is explained in the form of a flowchart. Okay. Now a programming example. If else statement. An else clause can be added to an if statement, then you'll get if else statement. If the condition is true, statement 1 is executed. If the condition is false, then statement 2 is executed. One or the other will be executed, but not both the statements will be executed. This is the program example and the logic of the if else statement. Nested if statements. The if statements could be nested within if block or else block. Suppose if another if statement is inside another if statement or else statement, then it is said to be nested if statements. Okay, an else clause is matched to the last unmatched if, no matter what the indentation implies. So in order to avoid confusion, you better use braces. This is an example for nested if statement. See here, if I value is less than 15, then inside this I value we will again check whether I value is less than 12. If it is less than 12, then we'll print, else we'll print something else. The switch statement is Java's multi-way branch statement. It provides an easy way to dispatch execution to different parts of the code based on the value of an expression. It often provides a better alternative than a large series of if-else statements. In each and every switch statement block, a break statement is mandatory. The break statement causes control to transfer to the end of the switch statement. If a break statement is not used in each and every block of the switch statement, the flow of control will continue to the next case also. Sometimes this may be appropriate, but often we want to execute only the statements associated with one case. A switch statement. This is an example switch statement. This switch statement functions as follows. Based on the value of option, either case A or case B or case C will execute. Suppose if case A executes, that is, if option is equal to A, then A count variable is incremented, and it, because of this break statement, it comes to the end of the switch statement. Suppose if the option value is B, B count plus plus is executed, that is incremented, and break statement is executed, so it comes to the end of the switch statement. Same holds good for this last option. A switch statement can have an optional default case. The default case has no associated value and simply uses the reserved word default. If none of the cases are matching, then the default case statement will be executed. In the absence of default case statement and no other values are matching, the control falls through the switch statement and it goes and executes the next statement following the switch statement. The expression of a switch statement must result in an integral type, which means it should return either an integer value or a character value. It cannot be a Boolean value or a floating point value or any other integer type. The implicit Boolean condition in a switch statement is equality. You cannot perform relational checks with the help of a switch statement. This example shows the switch statement usage. Here, based on the value of category, the grade is decided based on this case 10, 9, 8, 7, 6. There are totally 4 cases, and if it is not matching any of these 5 cases, then it executes the default case statement. See, at the end of each case, you are having a break statement. Otherwise, what happens? If this particular case is matching, it executes and it will start executing all the subsequent cases also. It becomes a logical error in the program.